we're going to explore how to work with fractions and combining, adding, subtracting fractions using our identities. One of the things that is going to be really powerful for us is using conjugates. So you can see here in this problem with the secants that we have secant x minus 1 and secant x plus 1. Well, common denominators would be great. They need each other and they happen to be conjugates. So I'm going to take the first fraction here that has a denominator with a minus 1, and I'm going to multiply numerator and denominator by the conjugate of it, secant of x plus 1. And the second fraction needs the minus 1, so the secant of x minus 1 times the secant of x minus 1. Keeping the values the same, getting a common denominator. Now my common denominator, when I multiply out secant of x plus 1, and then I'll have secant of x minus 1. In the numerator, I have just 1 times those things. So I have secant of x plus 1 minus the whole quantity secant of x minus 1. Simplifying on the top, I'm subtracting the secant of x, therefore the secants add to 0, and then I'm adding a 1. So I had a 1 plus a 1, so that's just 2. And then in the denominator, I have secant squared x. I'm distributing this, boxing it, secant squared x. And then my middle terms will go away, and I have a negative 1. And secant squared with a 1 looks really familiar. In fact, secant squared itself is just 1 plus tan squared, so I have 2 over 1 plus the tangent squared of x, still have the minus 1. So I replace that. That means that my 1 and my negative 1 will go to 0, so I have 2 over tangent squared of x. And if I have a tangent squared in my denominator, that means I'm dealing with a cotangent squared. So this is 2 times the cotangent squared of x. And that's as simple as we're going to get it in terms of one basic trig function. The next one, I definitely have different denominators again, so we will get common denominators as our first order of business. So I'm going to multiply this one by sine x over sine x. And this one is going to get multiplied by 1 minus the cosine of x, because that's what it needs for its denominator. So each fraction individually, I have sine squared x, and that's over sine times 1 minus the cosine. Then the second part, I have right here multiplying 1 minus cosine x by itself. Again, we're going to distribute in that area. So this is going to be plus 1 minus 2 cosine of x plus cosine squared of x. Again, we're doing this. 1 minus cosine of x, 1 minus cosine of x, multiply it out, and this is the combination that you end up getting. Now let's take a look at what's happening in our numerator. There's some stuff to get rid of here. When I combine sine squared x with cosine squared x, that Pythagorean identity says it's just 1. So in combination with this one, I have a 2 and a minus 2 cosine of x left on the top. And here I still have sine x times 1 minus cosine of x. I decided not to multiply that out because most of the time having your denominator factored is a good thing. I can also see where here in the numerator they both have a 2. So if I factor out a 2, I would have 1 minus the cosine of x. And I've got a sine and a 1 minus the cosine there. And I have a common factor of of 1 minus cosine of x. Therefore, I just have 2 over the sine of x, which is okay. But if it's in the denominator, that also means that it's a cosecant. So 2 cosecant of x is probably the best simplification for that one. The next couple problems involve some factoring. We like to look for our factoring patterns in here. This one I see I've got a cosine squared and I have a sine x. I don't like to have both of them in a factoring problem. If it was just one of them, it would be easier to deal with. Well, the one that's easier to change is not the sine, it's actually the cosine squared. So I'm going to use my Pythagorean identities here. I know that this is going to be coming from sine squared x plus cosine squared x is 1. If I solve for cosine squared, I will have 1 minus sine squared x. So that's what I'm going to replace right here in the next step. 1 minus sine squared x, still minus 1. And now I'm going to, recombine and see what I can get. So cosine squared x has been replaced with 1 minus sine squared x. So I have a negative sine squared x, a positive sine x, and my plus 1 and my minus 1 have added to 0. So I can see here I have 2 terms, a binomial. I've got a sine squared with a negative 1 coefficient and a sine of x. So this is going to be a very simple factorization where they each have a sine x, and I need a negative 1 sine x plus 1 to make that happen. So there is the simplification for that particular expression. Okay. The next one, sine squared x, cosecant x. I don't like that cosecant being in the denominator, so I'm going to think of this as 2 times the sine of x plus 1. And this is setting up very nicely because I have all sines. When you see this, I want you to think about letting a equal the sine of x. When I do that, I have a squared plus 2a plus 1. We know how to factor that. That's a plus 1 times a plus 1. Well, now let's put the sine x back in. Therefore, this is going to factor as sine of x plus 1 and sine of x plus 1 again, or you can simply say that it is the sine of x plus 1, but that quantity squared, it's multiplied by itself. With the last one in this video, we are going to be rewriting the expression as an expression of a single trig function again. So our goal is to get it to just one and not a combination of, in this case, tangent and secant. So I like to look for my squares anytime that I can. And I see that I've got a secant x plus 1 and a tangent squared. Well, I have a Pythagorean identity that uses tangent squared. 1 plus tan squared of x is secant squared of x. If I can solve this for tangent squared, which I can, that's the secant squared of x minus 1, since the 1 over. So my numerator, I'm going to switch out for the secant squared of x minus 1 and leave this here in the denominator. And this is great because this numerator is actually a difference of squares. It will factor, just like any difference of squares does, into the secant of x plus 1 times the secant of x minus 1. Again, we're thinking of this as something like a squared minus b squared. which we know factors into a plus b times a minus b. Keeping my denominator, secant of x plus 1 as a whole thing. You can see we've got a common factor of the addition. Therefore, this simplifies to just the secant of x minus 1. Single trig function, and that's all we needed.